And we are live on the Voice of the Cape Facebook and YouTube platforms for our Matric Revision session. We taken a bit of a break, but we're back, Alhamdulillah. And my guest today is Muntasir Kadri. And Muntasir is a tutor at Intune Tutoring. They offer online tutoring, and today the topic is financial mathematics. Muntasir, welcome.
Okay, shukran. It's been a while. It's good to be
Yes,
back
yes.
though.
So just in terms of today's session, what will you be covering just briefly?
So we will be covering financial mathematics. We'll be looking at things like compound interest, um, uh, basically examples involving loans and the depreciation value of certain fixed assets. Yeah, so it's basically everything finance related in mathematics, and often students just get confused with regards to which equations they need to use, and that's kind of what we'll be going through.
Wonderful. So do take full advantage of the sessions, and remember it is recorded. You can always refer back after the program has ended. And I hand over to you, Muntasir.
Okay, shukran so much. Okay, assalamu alaikum, everybody. So, today we'll be looking at finance or financial mathematics, specifically for the matrix. And yeah, let us jump straight into it. And we'll be looking at this first question here. And it says a farmer bought a tractor for 980,000 Rand. The value of the tractor depreciates annually, excuse me, at a rate of 9.2% per annum on the reducing balance method. Calculate the book value of the tractor after 7 years. So the important pieces of information here is going to be the fact that, oh, guess what? The value is depreciating. So that's a very important note to take, which means that we're going to need to use the formula that has the operator of subtraction. Okay, we have our values over here. We have our interest as well at 9.2%. And we need to note that in the formula, we need to convert this 9.2% into a decimal. And we do that by saying 9.2 divided by 100. And you'll see it in the formula shortly. And they state that it is per annum. It's not monthly, it's annually. Okay, so this actually allows us to use a very simple equation. And they say calculate the book value of the tractor after how long? 7 years. So what we'll do is we'll go straight to the working out and we'll take a look at it. And you'll see that this is a very simple problem to solve. So if we go here, we can see that they're going to be using this formula. I'll just scroll up. Okay. And the formula is A is equal to P 1 minus I to the power of N. So it's important to understand what these values stand for. P over here, this P symbol is indicating specifically the value, the valuation of the tractor, basically the value at which you bought the tractor, right? So 980,000 Rand. And after some time, this value is going to depreciate. It's not going to remain 980,000 Rand year after year. Okay. And the formula states A equals P1 minus I to the power of N. I is our interest rate, right? And we know that the interest rate is annually, not monthly. Right? So I'll show you something interesting. I'll just write it over here. So if our interest rate, and I'll just use a different color, right? If they tell us we are, go here, if they tell us that we are annually being affected by the interest rate, and let's say our interest rate is 9%, right? We will end up with our I value equaling 9 over 100, right? Which is going to equal 0.09. But because it's annually, we can state that it's over 1, indicating per year, right? Now, you don't have to input this one. This is just for me to show you something regarding these calculations and interest. If it states monthly, okay, then we're going to end up saying 0.01 over the amount of months that exist in a year. So we say divide by 12, right? And then you're going to get things like quarterly, semi-annually, and so on. Quarterly would be, you say 12 divided by 4. Right? So that would be, so you're just going to end up saying 0.09 divided by 4, and then semi-annually would be 0.09 divided by 6. Semi meaning half a year, right? So let's go here. Can go back. Okay, and we can see here that they're showing it's 0.092. So if we go back here, we'll see, 9.2% divided by 100 will give us this value of 0.092. They then tell us that it's over 7 years. Now, N represents the number of years in this formula. Okay, and this A value is our depreciated value. And we'll find that our answer will be 498,685.82. Fairly simple, only for 3 marks. Right? You'll get a mark for using the correct formula, for doing the correct substitution, and for your answer. Okay, 8.2. How many years will it take for an amount of 75,000 Rand to accrue to 116,253 Rand and 50 cents in an account earning interest of 6.8% per annum compounded quarterly? So look, this is stating quarterly. Right? Remember, I told you, you get monthly, semi-annually, quarterly, and this is often what throws students off when they see things like that. Don't be thrown off by it. You know that a quarter is 1/4. So how do we incorporate that? Okay. Now we know that it's accruing, right, which means it's increasing in value. We can see this here. Okay, they want to know in how many years. So if we look, the previous formula we used was A is equal to P 1 minus I to the power of N, right? But in this case, this was for depreciation. For appreciation, we will just change the operator from a negative to a positive, right? And that should be the formula they are using. And we take a look at the memo, and we see that over there. That is the formula that they are using, right? So if we carry on, take a look here. Now they're going to substitute the values in. So I'll just do it on my side quickly. I'll just grab this. We can just do it on this page here. Right, so I'll just give you an idea. So A is equal to P 1 plus I to the power of N. Okay, so they want us to figure out N. We don't know what N is. So we need to substitute our values in. So we know the value accrued to 116. So we can put this value in over here. 116,253. The original amount that was input, which was 75,000 Rand. 1 plus I, which is 6.8 divided by 100, which is 0.068. Right. Now notice they say quarterly. So if we go here, that's what they did. They put it over 4. Remember, I told you quarterly just means 1/4. So we go here, and right. So this is going to be, let me just make this neat. 0.068 over 4. Now remember, N represents the number of years, but because it's quarterly, we're also going to affect this exponent with over 4 as well, right? Because this is number of years divided by 4, because it's been affected, because it's compounded quarterly. So we need to input that information here as well. Now, this part may throw you a bit off. You're probably wondering, well, how do I resolve for this N over 4? I mean, I need to get this to be the subject of the formula. Well, let's take a look. So we just solve for the values that we can solve for, right? I'll divide this by 750,000. I mean, 75,000. Okay, we solve for this information in the brackets, and 0.068 divided by 4 plus 1 gives me a value of 1,017 N over 4. And we solve this on this side. and we get a value of 1.55 is equal to 1,017 n over 4. Now, what do we do from here? Well, all we do is we use logs. And we just place over here, we say this is going to be log 1.55. And if we log this side, the n over 4 will go over here, and this will become log 1,017. Now we can divide the logs, and we'll just get n over 4 is equal to log 1.55 divided by the log of 1.017. And this will give us a value of, let's see, log 1.55 divided by the log of 1.017. And this gives me a value of 26. Now guess what? We end up with n over 4 is equal to 26. And therefore n is going to be 26 times 4, which gives me a value of 103. Well, 104 because 103.99. Let's see if we are correct. It seems a bit odd. 104 years does not look right. But let's take a look here. Oh, sorry. I said, my apologies. I was supposed to say 4 times n, not n over 4. Right? So I kind of rushed the process there. So I made an error. And that's why that number was so large. So we did everything correct with regards to the logs. Right? The mistake that I made was that I said, if you look over here, I said n over 4. So this was supposed to be 4n. Right? So that which makes sense because if we're compounding something quarterly, that means within 1 year we are doing 4 times 4 times the interest within 1 year. Right? If it's something's compounded semi-annually, we are doing 2 times the interest within those per year, basically. Right? And if it's compounded annually, it's only 1 times the interest within that year. So this is supposed to be 4 times n, 4 times n, 4 times n, right? And then this value is just too big. This was supposed to be 4, this value divided by 4. And then we find that it's going to be 6.50 years, according to the calculation. All right. So let's look at the next one. So just be careful with that. If you rush things, you'll make silly errors like I did over there. So just be careful with this over here. Just remember that the interest is going to be divided by 4, but the number of years gets times by whatever they are stating the amount of compounds are going to be within that specific year. Okay, now let's look at 8.3.1. Tabu wanted to save 450,000 Rand as a deposit to buy a house on the 30th of June 2018. Okay, he deposited a fixed amount of money at the end of every month into an account earning interest of 8.35% per annum, compounded monthly. His first deposit was made on the 31st of July 2013 and his 60th deposit on the 30th of June 2018. Calculate the amount he deposited monthly. So first thing to understand is what formula it is that we need to use over here. And if we take a look at the memo, we're not using this formula here. Instead, we are using this one over here. But we can notice something interesting, how similar this formula has this specific term over here placed in as well. So F represents the amount of money that was initially deposited, right? So if we go here, okay, sorry, it's amount of money that he wanted to save as a deposit, which is what I stated, 450,000, right? And we have our X value over here. This X value is going to speak about the amount he deposited monthly. Right? So X represents the monthly deposit. F represents the amount of money he has to save for his a deposit to buy a house on the 30th of June 2018. And N represents the number of deposits. I represents the interest rate. Okay. Now, let's see what they say. If we highlight our information, we can see here that they are saying the deposit is monthly, right? Not annually, not quarterly, not semi-annually, but monthly. So what we end up doing is we're going to divide the interest rate per month. So it's going to be 8.35% per annum. So that's telling us that's the interest rate per year. But if we are calculating this monthly, we have to then divide it by 12. And that's precisely what they do in this formula over here. If you look here, they use this formula, and in there we see 0.0835 divided by 12 to the power of 60, which is the number of deposits, minus 1. And also over I, so the same thing over here. We solve for the formula as seen here, and then we'll be able to solve for x, and we'll get an answer of 6,068.69. So this one is not too hard at all, only for 3 marks, okay? Financial maths is pretty easy. It's just a matter of knowing which formula you need to use under certain situations. All right. So let's go down to 8.3.2. Okay. Now they state Tabu bought a house costing 1.5 million and used his savings as the deposit. He obtained a home loan for the balance of the purchase price at an interest rate of 12% per annum, compounded monthly over 25 years. He made his first monthly installment of 11,058.85 towards the loan on the 31st of July 2018. What will the balance outstanding on the loan be on the 30th of June 2039, 21 years after the loan was granted? Now, we're going to be using a similar formula to what we use in 8.31. So let's take a look. All right. So here we go. So here we have P, which is going to indicate the outstanding balance. Okay. All right. So this is, of course, us paying off the loan. Right. So there's going to be a depreciation in certain values and an appreciation in others. We'll have an appreciation in values on the amount of money that's left over after each installment, which is what you're seeing over here by the 1 plus I. That's an appreciation formula. And here they're saying to the minus n. Okay. And this is indicating that we are, of course, being affected by the number of years over which the loan was granted. This formula, however, is a little bit tricky to use. I would rather advise you, in my personal opinion, to use this formula. It's a lot easier. In fact, it's pretty much way more obvious. It says the balance is equal to A minus F, where A is represented by this appreciation value over here for compound interest. This is a compound interest formula. Okay. And then the compound interest formula is subtracted from this formula over here, which was using 8.3.1, which is for deposits. Okay. So if we take a look, what do? Well, first they take the p-value, right, which is the value of the house. Remember, your p-value is always the value of the item or the asset that you are purchasing. Okay, they made a bit of an error here, right? So it's actually supposed to be 1,500,000. So what we'll do is we'll just grab this here and we'll paste it on our current page, and we'll just we'll redo the formula. Redo the equation to get the correct answer. Add to new page. Go here, and let me just get this question. Here we go. Right. Add to current page. Here we go. Right. So now let's resubstitute this information. So just remember, balance, whenever they ask about an outstanding balance, you just go ahead and use this formula where you say balance is equal to A minus F. And you need to, well, the formulas will be available on your formula sheet. This is for compound interest, and this is for the deposited amounts. Now, let's substitute the values in. So, P is 1.5 million. 1 plus our interest rate of 12% per annum. So that's going to be 12. It is monthly. So this should be, 12 divided by 100. 0.12 divided by, because it is a monthly installment, we just say divided by 12. Right? And n is the number of years. So 21. Right? Now let's see if this matches what they did in the memo. And we'll see now. And there we go, 21. All right. Oh, my apologies, 21 years, but we're doing it monthly. So therefore we say 12 times 21, which is correct. So we just put that in here. All right, there we go. That's for monthly. Now, we subtract this. Our x value in this case is going to be, where's this now? Here we go. The first monthly installment. Okay, 11,058.85. Yeah, we substitute that in. Oh, I forgot I had it up here. 11,058.85. Okay, square brackets, 1 plus 0.12 divided by 12. That's 12 times 21. Made a little mistake. Okay, I'll just do this quickly. Erase this. There we go. Make this. There we go. Minus 1 over 0.12 over 12. Now, let's see what we end up with. Input this information on my calculator. It's 100, let's see, 1,500,000, that's right. 1 plus 12 over 12. Close that bracket. No. Give me a second. Oops. No, that's not it. Why are you not closing the formula? Sorry, give me a second. Here we go. Okay. To the power of 12 times 21. Okay, and that gives me a value of 184,11003.15. Okay, now we go here. So let's check how close they were. So we can see that this value is quite off because of this change over here, right? So that caused an error. And then we end up with this value over here, 12,467,749. So we can subtract it from 12,467,749.81. Right. And we'll find out that the balance left over for Tabo to pay is going to be 184,11003.15 subtracted from 12,467,749.81. And that gives me a value of 594,3253,34 rands. And that is the outstanding balance on the loan right after 21 years. There we go. So it seems a little bit complex, a formula, but it's actually fairly simple because all we're doing is to find the balance. We are just taking the compound interest formula and subtracting it from the formula for the deposit formula, right? Here we go over here, right? And of course, the deposit is also affected by this compound interest. And there we go. Easy peasy lemon squeezy, right? Now, let's look at the next question over here. Okay. Then they state, calculate the interest Tabu will have paid over the first 21 years of the loan. Right? Um, isn't this B? Oh, it is B. It's A twice. Right? So it's a fairly short to do to this. It's literally total paid, right? Which is this value over here. Okay, where we say 11,000. So we have to take the deposit that they paid monthly, times it by 21, times it by 12. Okay, that would work out to be the total amount paid, because he's, of course, Tabu's paying this monthly installment every month for 21 years, 12 months of a year. Okay, so we have to say 21 times 12 times this amount of a year. That's the total amount paid. Then we look at the amount for the loan paid, right? And the amount for the loan paid is one. So this is what's left over from the loan. And this was the initial, this is the balance outstanding, which is over here. And this here is the initial payment. And if you look here, which was you bought the house, that's the valuation of the house. So you take the valuation of the house and you subtract it from the balance outstanding. Right? And then what was paid in the loan was 630,051. And to find out what the interest is that had to be paid, well, we subtract the total paid from the amount from the loan paid. And this is the interest paid, 2,156,782.52 cents. So that's kind of scary, because if you look at the valuation of the house and the interest paid, well, I mean, if Tabu could have saved the cash under his bed, right, and just paid for the house without interest, that would have been a great thing. But unfortunately, Tabu cannot do that. So, you end up paying back the bank quite a bit of money just with regards to your loan that you took out on your house. Okay. And that's how you would solve that. Not too complex. So just remember that it's going to be interest paid is equal to the total paid subtracted from the amount of the loan paid. Now, let us go down and we can go to the next question. Here we go. Example 2. So we're basically going to be following the same trend now with regards to example 2 as well. So let's take a look. So 6.1. On the 31st of January 2020, Tsepo made the first of his monthly deposits of 1,000 Rand into a savings account. He continues to make monthly deposits of 1,000 Rand at the end of each month, up until the 31st of January 2032. The interest rate was fixed at 7.5% per annum, compounded monthly. What will the investment be worth immediately after the last deposit? So, once again, we are now looking at one of those deposit questions. So, what formula do you think it is we would need to use? Right? Well, first monthly deposit of 1,000 Rand into a savings account. He continues to make monthly deposits at the end of each month up until the end of January 2032. So we need to take into consideration how many years he's been paying this deposit over 12 months, right? Monthly. So we can see that is 12 years. So we're going to end up having something like, 12 years times, 12 months, which would indicate that he's paying it over that period. So we know there's going to be that. And then there's the interest rate with a fixed at 7.5%. So we can have 0.075 divided by 12 as well. And it's compounded monthly. So we, of course, going to use this formula again with F. There we go. Right? So once you see the word deposit, you should immediately know this is the formula you are going to go to. Okay, where X is the monthly deposit being paid, and F represents the value of the investment. What will the investment be worth immediately after the last deposit? So now let's see. Let's take a look. Now we go here. And all we do is we just substitute the values in. So what I'll do is I'll just grab this formula and I'll add it to a new page. and we will take a look at the question. I'll go back here, grab this, and we'll do this together. Okay, so now there's our formula, which you'll find in your formula sheet. And we'll go ahead and we'll just start inputting values, right? So we know, if it helps, on the side of your page, write down what you think the values are. Well, X is 1,000 Rand. We'll do that before we even substitute it in, right? And we can see, well, we got 1 plus I. Well, we know I is going to be equal to 7.5 divided by 100 divided by 12. So it's going to be 0.075. And we say divide by 12 because it's been compounded. Excuse me. It's been compounded monthly. Now, N is going to represent the number of years. We know it's going to be 12 years, but it's every month. So 12 times 12, right? And then I, once again, is this value over here. So let's see if we get this right, because we did this. Now we substitute the values in. So F is equal to 1,000. 1 plus 0.075. And because they tell us it's compounded monthly, we have to say divided by 12, which is what we stated over there. And this is going to be 12 times 12, because it's 12 years times 12 months, minus 1 divided by the 0.075 over 12. Now, does this match what they have in the memo? Let's take a look-see. Right, and there we go. So they got a value of 145 over here. Let me see something. 12 times 12 gives me 144. Why is there an extra year? Is my question. Let's take a look. Maybe I made an error. No, it is 12 years. Maybe there's 1 year I'm missing, or 1 month I'm missing. I might be missing a month. Let's just double check. It might come to 25 because there's an extra month. Interest rate was fixed at 75% compounded monthly on the 31st of January 2020 to the 31st of January 2032. That is 12 years exactly. I mean, from January to January is a year. No, it's from January to this 31st of January to 31st of January 2032. Let's just think about this. From January to December is 12 months. So if they had to say, if it had to go to December 2031, then it would have been 12 times 12, apparently. So there's an extra month available that was paid for. If I work it out, let me just check on my calculator. All right, so that's the first. Let's just see here. Let's see something. 31st of the 1st, 2020. And we have 31st of the 1st, 2032. That difference is 12 years. So the issue just lies here. So from the 31st of January till the 31st of December is 1 year. All right. Right. There is 1 month extra. Yes. So there is 1 month extra because we are going to say from the 31st of January 2020 to the, so you have to be careful with this, to the 31st of December 2031. This is actually the equivalent of 12 years. Right, and then we can say 12 times 12, but then there's going to be 1 month left over, which is the 31st of January 2032. So that is why they ended up using the value of 25 instead of 24. I hope that clears some things up. And that is why we end up with 25 instead of 24, because there's one extra month available. Right? So this is 25. So that's a little bit of, that's sometimes how they try to slip you up and then, trick you within question paper. So just be very careful with your calendar information, unless they state quite clearly that it was 21 years or 23 years or whatever the case may be. And then, of course, this information is all correct. And if we look at the memo and we see the answer, we end up with a value of 234,888.53. Okay. We're going to look at the next one quickly. Okay, so 6.1.2. If he makes no further payments but leaves the money in the account, how much money will be in the account on the 31st of January 2033? And this is for 2 marks. Okay, so he makes no further payments but leaves the money in the account. Let's take a look, right? So because we're just going to go ahead and use the compound interest value. So we take this value over here, which we calculated, then what the investment is worth. Okay, so we left this investment in his account after 2032 for 1 year, still being compounded monthly, right? Leaves it in, and we notice that we end up just using this value, using the same interest rate, and just putting it to the power of 12, because it's been done monthly for 1 year. And this is what the value is for the compound interest acquired on that investment. Okay, fairly simple enough. Let's go on to 6.2. So 6.2, they are now speaking about depreciation. So we'll grab this, let's just add it to a new page. So Jim bought a new car of 250,000. The value of the car depreciated at a rate of 22% per annum. Annually, right? According to the reducing balance method, after how many years will its book value be? 92,537 and 64. So we go ahead and we use this formula. A is equal to P 1 minus I, because it's depreciating, to the power of N. Now, A is going to be the new book value, which is 92,537. 64. P is going to be the price for which you bought the car. So the original valuation. I is our interest rate, and because it's just going to be 22 over 100, and it's annually, so we don't have to worry with dividing by anything, although it is being divided by 1, that's going to give us a value of 0.22. Okay, N is the number of years. This is the value that we need to find. So we substitute all this information in, and we'll get 64 is equal to 250,000, right? 1 minus 0.22 to the power of N. Okay, we can straight up divide these two values. And let's see, 92,537.64 divided by 250,000 gives me a value of 0.37 is equal to 1 minus 0.22, 0.78 to the power of N. And we use logs. Divided by, so I just skipped a step there, is equal to N. Therefore, N is equal to, let me just put this value in, and we get an answer of 4 years. Is this correct? Let's check. And there we go. We get a value of 4 years. Okay. So won't have enough time to do the last two questions, but they are fairly simple. They're going to follow the same order. We can see that this is following the deposit, right? So loan amount, and then the balance after 5 years. Of course, we can use the method where we use balance is equal to amount paid minus a loan minus balance, right? So if you'd like, this information will be available on the website. You can access these questions with the memos available to you, and you can go ahead and practice these examples. Okay, financial maths can be a little bit tricky, and that's just with regards to knowing what type of formula you need to use. And of course, when it comes to working out your balance, you just have to be a little careful with regards to which values are going to use and which values are going to subtract. Okay, don't forget also there are things like terms like semi-annually, quarterly, and monthly. You need to remember to incorporate that information into your equations when you're looking at your interest and when you're looking at the number of years you are working with. All right. So that's all from me for today. I hope this assisted you. You can go straight to the website. It is over here. Let me just zoom out. www.intitutoring.co.za, or you can contact us directly on 082 705 9913. I hope this was helpful. Enjoy the rest of your day. Assalamu alaikum wa rahmatullahi wa barakatuh.
Salam Muntasir. It's Daniel here. Konita had to take a step out for personal reasons. So I apologize for that. But shukran so much for doing the live stream as you always do with the absolutely enlightening. I did not understand a word of anything you said because, as I told you before, I got 50% for the subject and I'm trying to forget it ever existed actually. But I make the ask for all the students out there that they don't get 50%. I know you guys can do it 10 times better than what I did. But shukran so much, Muntasir. It's been absolutely fantastic.
Afwan, no problem. I hope you don't have any loans to pay off. Otherwise, you're going to need to know how to calculate your compound interest.
I don't want
But
to. I don't want to get into my debt. I don't want to have a discussion about my debt right now because that is a whole other ball game. I don't want to get into that. But shukran so much, Muntasir. It's been absolutely a pleasure.
Afwan, not a problem. Enjoy the rest of your day. Salam.
Salam.